This is Northern Oklahoma College, College Algebra, Math 1513, Chapter 1, Section 4. I'm doing an example for your assignment number 1 problem, and we are solving polynomials by factoring. All right, when you see something with two terms like this, we have two terms, one term, two terms, x cubed minus x equals 0. The first thing I ask myself is, what can I factor out of that? You see, that's a subtraction problem there, and we want to turn it into multiplication so that we can use our zero product principle rule. When you have a subtraction problem or an addition problem, not much we can do with it, so we have to turn it into multiplication. So I'm going to do that by factoring something out. I ask myself, what will go into x cubed and x? Well, if you think of x cubed as x times x times x, and then just our other x over there, our second term. If you think of it in expanded form like that, when you write it in expanded form, you write it using multiplication instead of exponents. When you write it in expanded form like that, sometimes it makes it easier to see that these guys have an x in common. I could actually divide each one of those by an x. Now this x that we're dividing out, that's called our greatest common factor. It's the biggest number we can pull out of both of those. That greatest common factor goes in front of our parentheses. It's going to go right there. What goes in the parentheses? What goes in the parentheses is everything that's left over after I get done canceling. So when I cancel these x's, I still have an x squared left over. And when I cancel these x's, well, you want to say there's nothing there, but actually when you cancel, things turn into ones. And so 1 divided by 1 equals 1. So I have a 1 there, and here's my minus sign in between them. So we have our x times x squared minus 1 equals 0, which is good. We have changed a subtraction problem into a multiplication problem. Now before I go on, I noticed that there's a special pattern right here. This x squared minus 1, by now you guys should be able to recognize that's a special pattern. It's going to factor easily. And it's going to factor into x minus 1, x plus 1. Now don't forget, you still have that x out front. So now we have three factors. Where are they? You have one right here, and right here. How do you know what a factor is? A factor is anything that's being multiplied. So the x is being multiplied. This group, x minus 1, that whole group, that's a factor. And this group right here, x plus 1, it's being multiplied. So that whole group is a factor. Now that I have them broken into factors, I can take each factor and set it equal to 0. So my first factor, x equals 0. My second factor, x minus 1, is equal to 0. And my third factor, x plus 1, is equal to 0. I solve each of them. This one's done. This one I have to add 1 to, and I get x equals 1. And this one I have to minus 1 from both sides and get x equals negative 1. Now the best way that I can think of to write the answer is, we could write x equals 0, comma 1, comma negative 1, but that's kind of like using bad grammar. Better grammar is going from low number to high number. So I'm going to write negative 1, comma 0, comma 1. That's how the book does it, from low number to high number. All right, our next problem is an example for your problem number 3. Now notice that we have 4 terms here. First term, second term, third term, fourth term. And whenever I see 4 terms, the first thing that goes through my head is I'm probably going to factor by grouping. All right, and I'm going to try and take these numbers in the order they are. So I'm going to group the 4x cubed and the 4x squared together. I'm going to try that group and see if I can factor something out. And I'm going to take the minus 9x minus 9 and call that a group and see if I can factor that out. And in this case, it's going to work out nicely, but sometimes the book is diabolical and they put the terms out of order, and you have to figure out which two terms go together. I can tell here that these guys share a 4 and a couple x's. And I can tell these guys here share a 9, so I'm going to factor those out. Just like we did in the last example, I'm going to see what they have in common, and I'm going to factor it out. All right, my first pair, 4x cubed plus 4x squared, has a 4x squared in common. That's their greatest common factor. I'm going to factor that out, and it leaves an x, and there's my plus sign. And then 4x squared divided by itself, 4x squared, leaves a 1. So when I divide the first two terms, I get 4x squared times the group x plus 1. The second pair over here, these guys, looks like they have a 9 in common, but I'm actually going to factor out a negative 9 because it works out nicer, and you'll see in a minute. So I factor out a negative 9, and I have an x and a plus 1. Now how do I know to use those? I just in my head, I do the distributive property and make sure that I still have what I started with. I started with a negative 9x minus 9. And when I rewrite it, I want to make sure that I still have a negative 9x minus 9. So I check it by multiplying negative 9 times x. That's negative 9x. We're good there. And negative 9 times positive 1 gives me a negative 9, which is what we started with. So we rewrote it, and we didn't change anything. Everything's good. Now remember, when we find something that they have in common, we put it in front, and then in the parentheses we put what's left over. Same thing with the 9. We saw they had a negative 9 in common. We put it in front. We put the leftovers afterwards. We're going to do the same thing here. It's just like doing the same song, second verse. So let's do it again. What do these guys have in common? I notice that they have an x plus 1 in common. So I'm going to put that in front, just like we always do. We find what they have in common and we put it in front. What goes in the parentheses right next to it? The leftovers. And what's left over after I take these out? The 4x squared and the minus 9. So they go in the, our leftover parentheses. We still have equals 0. And now we have changed up here. We changed an addition and subtraction problem into a multiplication problem, which is good because once you turn everything into factors, we can use the zero product principle and figure out the answer. Now, if you'll look at our second term here, our 4x squared minus 9, anytime you see an x squared, that's kind of a clue that you have more factoring, all right? More factoring to do. So what can I do with this? Well, if you look a little closer, that resembles your a squared minus b squared pattern. And it would resemble it even more if the 4x squared was written like this instead, because 2x times another 2x is 4x squared. And if the 9 was written like this instead, because 3 squared is the same thing as 9, then this would be your A, and this would be your B. So that's one of those special patterns we talked about earlier. All right, so after factoring our special pattern, we have x plus 1 times 2x minus 3 times 2x plus 3. We have turned our addition and multiplication expression from the very first line, our addition and subtraction problem from the very first line into a multiplication expression, which is good because now we have 1 factor, 2 factors, 3 factors. We set each one of those factors equal to 0 and solve, and we have our answer. So x plus 1 equals 0, 2x minus 3 also equals 0, and 2x plus 3 equals 0. We have to set each of those extra equal to 0 because somebody has to equal 0 for all that to be multiplied and you get a 0. Finish solving here. X equals negative 1. You guys can do the algebra. X equals 3 over 2. And x equals negative 3 over 2. And it's just fine if you guys want to write the answer this way. If you want to write it in order from low to high, that's also great. Now I put this example on here. This is actually your assignment number 7. I'm not going to work it for you, but I'm going to show you. This is one of those examples where you see 4 terms. So you're thinking, okay, I got to factor by grouping. But the book didn't put them in the right order, okay? If you group those two together, and those two together, it's not quite going to work into anything pretty. I'll show you. All right, did I say it wasn't going to work into anything pretty? I was wrong. It works out just fine. So you can factor it this way. I'm also going to show you that it would factor if you mixed up the terms. So for example, if I put 3x cubed here, and then I put my 27x next to it as a group, and then put my plus 2x squared here, and my minus 18 here. See, they're all in a different order, but it's actually still going to work out. And this one would factor a different way, but it actually works out to the same answer too. So there's a hint for you guys. That'll get you started. You can factor them either way. You can use method 1 as the book writes, or you can rewrite them like that too. It's going to work out either way.